All right, guys. So I shared another video with you in which I went through one of the problems on delta math and actually reduced the radical on there. But I wanted to take this time to do a few more examples for you guys. So what we're doing here is simplifying radicals. Okay, and this method I'm going to call the perfect square method. Okay, so there are multiple ways to simplify radicals. If you Google how to do it, you'll see several different ways to do it. This is one way that we're practicing today. So you guys have covered this in the past in Algebra 1. We also did something like this last week in CCR, but I just want to help you out in case you're still struggling with this, because I know this is not something you've done a lot of this year in geometry. So the perfect square method. First, you need to know what perfect squares are. Perfect squares are numbers that when you take a square root, you get a whole number as an answer. Okay, your examples are 1, 4, 9, right? Because the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, so 16 is 4 times 4. 25 is 5 times 5, etc. And I'm going to go up to 100, which is 10 squared. So that's the first 10 perfect squares. We're going to deal with just those today. So the perfect square method, if I'm given a radical, let's say 72, okay, my goal is to come up with a product of two radicals that will multiply to 72, and you want one of those two radicals to be a perfect square. Okay, so when you have no idea what goes into the number, let's say you can't think of one of these up here that goes into 72, start small. Start with 4. Does 4 go into 72? I go to my calculator. 72 divided by 4 equals 18. It works. Okay, so I'm going to say radical 72 equals radical 4 times radical 18. Now, the reason that you do that is because the square root of 4 is just the whole number 2. So now you've gotten rid of one of those radicals. Okay, now the next question is, can 18 break down into a product of two radicals so that one of these perfect squares goes into 18? Let's see. 4 does not go into 18, but 9 does. Okay, so now I still have this 2 in front, but 18 is going to break down into a product of two radicals. That would be 9 and 2. Okay, bring down that 2 again, and 9, the square root of 9 is 3. Okay, so now I've broken down even further, and you've been able to pull out a 2 and a 3. You multiply them and get 6, and your final answer is 6 radical 2. Okay, now just to show you what would have been easier, the fastest method to solve one of these problems is to find the biggest one of these perfect squares that goes into 72. And hopefully some of you guys realized that the biggest one that goes into 72 is 36. 72 is 36 times 2. 36 is the whole number 6 squared. And so you end up getting the same answer, 6 radical 2, whether you pull out a 4 in the beginning or whether you pull out a 36. Okay, so you're simplifying radicals by choosing perfect squares that multiply into that number. Okay, and then once you have a perfect square, like a radical 4, radical 36, they turn into a whole number, and so you're able to simplify that radical.